Oh, good morning. First of all, my sincerest thanks to you for doing that work, for emailing me, for sending me pictures of what you've done, for asking me questions, for asking me when the next stuff's coming out. Gentlemen, this is brilliant, absolutely brilliant. One or two of us haven't been so good at getting in touch. I can't stress how important it is. Even if you just send me an email saying, "Got the work, Mr. Fazzy, thank you," that's all I need. Now, we're close to finishing off this fraction business. We're going to look at something that very few people know about or really understand. It's called simplifying. Now, here are 7 fractions. Start off with a horrible big 64 over 128, 16 over 32 in the middle, and 1 over 2 at the end. A half. Something odd is going on here. Yeah, I have 7 different fractions. But the odd thing is that 64 over 128 is the same as 32 over 64. And that's the same as 16 over 32, it's the same as 8 over 6, it's the same as 4 over 8, 2 over 4, 1 over 2. They are all the same. That 64 over 128 is exactly the same value as a half. Now, I don't know about you, if I'm going to work with a fraction, I'd sure as hell rather work with a half than that. Someone comes round to my house tonight with a pizza and says, "You can take half." I'll go, "Oh, okay, thanks." Cut it in half, scoff that. If he rocks up and says, "Well, you can take 64 over 128, what are you talking? Now, there's that pizza. I've cut it into 2 bits and I've taken 1 of them. 1 bit out of 2, a half. Right? What if I'd done this? If I cut it into 4 bits and I've taken 2, well, how many bits have I got? 4. How many bits have I taken? 2. Have I still had the same amount of pizza? Yes. So in other words, 1 over 2 is the same as 2 over 4. And if I cut it into 8 bits, and I eat 1, 2, 3, 4 bits. There. So in other words, 1 over 2 is the same as 2 over 4 or 4 over 8. If I cut that pizza into 128 bits and I eat 64, I'm eating 64, I've got 128 altogether, I've still eaten a half. Now, what we have to be able to do is to take horrible, big, clumsy, nasty looking fractions and turn them into something that's nice and simple. That's why this is called simplifying. Right? Wait there for 2 seconds, I'll get rid of this and we'll look about how we're going to go about doing it. I'll be back in just 2 seconds. Please wait for me. Welcome back. Now, I've got this fraction, 8 over 12. I want to see if I can turn that into an easier fraction, something a bit more simple, something with a smaller number at the top and a smaller number at the bottom. Now, here is how I do it. I want to find the biggest number that I can divide into 8 and also divide into 12. Now, here's what I do. Some of us are very good at their times tables and they can see immediately what that number is. I can't. So what I'll do is, I'm always going to start with 2. Does 2 divide into 8? Yes. 2 4s are 8. Does it also divide into 12? Yes, it does. It goes in 6 times. Great. So 2 is a possibility. But I want the biggest number. Are there any other numbers that go into 8 and 12? Let's try 3. Does 3 go into 8? No, it doesn't. I'll end up with a decimal or a fraction. No. 3 does not divide into 8 a whole number of times. That's no use. What's next? I'll try 4. Does 4 go into 8? Yeah, it goes twice. 2. Does 4 go into 12? Yes, it goes 3 times. That's a possibility. Now, 5 doesn't go in a whole number of times, nor does 6, nor does 7, nor does 8. 4 is the biggest number that divides into 8 and into 12. Good. I want to use 4. And what I'll do is I'll go 8 divided by 4, and I'll go 12 divided by 4. 8 divided by 4 twice. 12 divided by 4, 3. Finished. So I've taken 8 over 12 and I've simplified it into 2 over 3. Should we try that again? Let's look at a different one. Okay, let's choose, I know, how about 15 over 25? Okay, biggest number that goes into 15 and 25. Start with 2. That's an odd number. 2 is even. 2 does not go into 15. Should we try 3? Does 3 go into 15? Yes, 5 times. Does it go into 25? Oh no, it doesn't. 4? Does it go into 15? No. 3 4 are 12, 4 4 are 16. No use. Try 5. Does 5 go into 15? Yes, it goes in 3 times. Does 5 go into 25? It does. 5 times. Oh, so 5 is a possibility. 6? No. 7? No. 8, 9, 10? No. The biggest number is 5. So I'll go 15 over 25. I'll divide the top number by 5, bottom number by 5. Same number into both. 15 divided by 5 is 3. 25 divided by 5 is 5. Right. There's 100, there's 10 over 40. Anyone spot the biggest number that goes into 10 and 40? 10. I can divide that by 10, that by 10, and I end up with 1 over 4. Now, sometimes you give you sneaky ones, and I hate to try and trip people up, but look at this. 7 over 11. Try and simplify it. Fine. Does 2 go into 7? No. Does 3 go into 7? No. 4? No. 5? No. 6? No. 7? Oh yeah, 7 divided by 7 is 1, but 7 doesn't go into 11. In other words, nothing I can do with that. I cannot simplify that further. Now, I'll be honest, this might not be the most exciting exercise in the world, but it's so important. It's a final bit in fractions. One more time. I get a fraction, and I want the biggest number that I can divide into the top and to the bottom. Now, I'll give you a worksheet with just 10 examples, guys. Again, have a go at them. Give me your feedback. Let me know how you get on. Right. Guys, again, I'm going to wish you all the best, and I'll send you an email tomorrow. talk to you.